1.2. okay, so this is also very easy questions, and here we have 7 questions which we will be doing it in within the one video. So all of you, I hope all of you have watched exercise 1.1 videos. If you have not watched, please go to the channel Kumar Sir, watch that exercise 1.1 video, and then you can switch to 1.2. okay, let's start. This is your channel Kumar Sir Mathematics. Let's start. Express each number as a product of its prime factor. So we are question number 1. They are telling express each number as the product of its prime factor. So here what we are doing, see here, question number 1, what is that? 140. So 140, if you take an LCM, if you take the LCM of 140, how it will be coming? 140 to 7 0 to 35, and here it will be how much? 7 into 5, right? So this one we have written here 2 into 2 into 5 into 7. So here in the next step, what we can write? 2 into 2 we can write 2 to the power 2, and this is what? 5, so we'll write it 5 into 7. So this is the form of prime factors. We have written this 140. This 140 we have written it as the product of prime factor. This is the product of prime factor. Okay, I hope you have understood. This is very easy one. Next, 156. So 156 LCM, if you take 2 7 is 14, and here it will be 8, 2 3 is 6, 2 9 is 13 into 3. So here we have written here 2 into 2 into 3 into 13. So 2 into 2, so we can write 2 to the power 2 into 3 into 13. So this is the product of the prime factors, okay, for 156. Similarly for 385, so 385, if you take LCM, then here 5 is there at the last, so it will be definitely going by 5. Okay, so we have written 5 7 is 35, and 3 then 6 30, and 2 5. So again it will be going by 5, 5 1 is 5, 5 5 is 25, and 1 3. So it will go now by 3, 3 5 is 15, and 3 1 is okay. Then finally it will be going by what? 17 3 is okay, 17 3 is 51. So you see here we have written same thing, 3 into 3, this 3 into 3, 5 into 5, 5 into 5 into 17, so into 17. So how many 3 are there? 2. So 3 to the power 2. How many 5 are there? 2. 5 to the power 2 into 17. So this is the product of the prime factors. Okay. Now similarly we will take the LCM for this also. So when you take the LCM for 005, it will be 51001. Okay. Now next it will be going by what? 11. So 11 9 is okay. It will go by 11, or you just try it by 7 also. I think it is possible. 7 to 7 1 is 7, 7 to 30, 7 4 is 28, 7 3 is 21. So next it will be going by how much? 11 13. So 5 into 7 into 11 into 13. So 5 into 7 into 11 into 13. Here no repetition, so no need to write like this, so we will be keeping it as it is. Similarly here also, if you take the LCM, it will come 17 into 19 into 23. So I think you have understood question number 1. Express the following in the as the product of prime factor, right? So we have written it. Now we are going to question number 2, which is also very easy, and let us try to understand it. Okay. Now question number 2, here what it is said. See, in question number 2, find the LCM and HCF of the following pair of integer and verify that LCM into HCF equal to product of the two numbers. That means we have to find the LCM and HCF of this number, and then we have to show that LCM into HCF is equal to product of the two given number. We have to verify it. So first let us try to find out the HCF and LCM, which one you know very well. So 26 LCM if you take, then it will come 2 into 13. 91 it will come 7 into 13. So LCM of 26 and 91. So LCM means what? Product of all. So here 2 into 7, and this 13 is in both, so only one 13 we will be taking. 2 into 7 into, here only one 13 we will take because it is common in both. So 13. If you multiply, you will get 182. Now HCF means what? HCF, always remember, HCF means the common one only. So here 2, do it has any common? 7, no common. So 13 only it has a common. So 13 will be the HCF. Okay, so HCF will be equal to what? 13. Now product, we are finding HCF into LCM, a 182 into 13, so you will get this much. Now product of the two given number, so two given number is what? 26 into 91, so we have multiplied 26 into 91, so we got how much? 2366. So you see, product of HCF and LCM and product of two given number, it is coming equal only. Hence HCF into LCM equal to product of two given number. Okay, this is what they are asking us to verify, or they are asking us to find out. So we have already done, so it is verified. Now we are going to next question, questions of question number 2. Question number 1 we have done. Now we are going to do question number 2, Roman number 2. So question number 2, Roman number 2, same thing, it's very easy. Okay, first of all you have to take the LCM of this. How to write the product of prime factor already we have done in question number 1 by taking the LCM. So this one we have taken the LCM. Okay, you have to take LCM of this one, 5, 10. Okay, LCM you have to take 2 2s are 4, 2 5s are 10, and then 5 is 10. 5 5s are 10, 25, 1, then 17 3s are. Okay, so you say 2 5 17 13. So 2 3 5 17 we have written. Similarly, you take the LCM of this, you will get like this. Okay, I hope you understand. You take the LCM of this one, so you get how much? 2 into 2 into 2 into 2, 23. So done. Now what you are going to take? LCM of 5, 10 and 92. It will be equal to, among these 2 and 2 to the power 2, which one is highest? 2 to the power 2. So we will take this one, 2 to the power 2 into 3 into 5 into 17 and into 23. So you will get the product this much. Now HCF of this one. So HCF, I told you, between these two there should be common one. So what is common here? Here it is 2, here it is 2 to the power 2. So only 1 2 is common here. So you will take here 2. Okay. Now we have to prove LCM into HCF is equal to product of two given number. Means LCM and HCF, whatever we got, if you multiply, you should get equal to product of 5, 10 and 92. That is given number. So we have multiplied, we got 4, 6, 9, 2, 0, but product of the two given number, the numbers are about 5, 10 and 92. When you multiply this, you are getting same. That means LHS and RHS is coming equal. Therefore, this is what they are asking us to verify. So it is verified. Okay. Similarly, question number 3, it is given here, this one 336 and 54 it is given. Okay. So 336, if you take LCM, then you will get 2 into 2 into 2 into 2. Okay, into 3 into 7, you will get like this. You have to take the LCM here. Okay, again and again I am telling you, you have to take the LCM. 1 6 8. So 2 8 4. So 2 4 2. So 2 2 1 7 3. So 1 2 3 4. So 2 to the power 4, 3 into 7. We have written it like this only. We have to take it. Okay. You have to take the LCM and then you have to write. So here also I have taken LCM, so you will get 2 into 3 to the power 3. Now LCM of 336 and 54. So between here we have 2 to the power 4, here we have 2. Among these two, which one is highest? 2 to the power 4. So 2 to the power 4 and 3 and 3 to the power 3. Which one is highest? 3 to the power 3. So 3 to the power 3 and here 7. We will take it. So when you multiply all this, okay, then you will get 3024. Okay, you will be multiplying, then you will get 3024. Now HCF, I told you only the common one. Here only 1 2 is there, here 2 to the power 4 is there. So only 1 2 from here and 1 2 from here. We will take it common. So 2 1 3, and here also only 3 3 is there, but only we will take 1 because 1 is common. So 3. So 2 into 3 is how much? 6. Now again verification. Now LCM into HCF is equal to product of two given numbers. So LCM is what? 3024 into 6, and product of the given number is what? 336 into 54. So when you multiply, you got it this much. It is coming equal, therefore it is verified. Okay, so this is about question number 2. Now we will switch to the Next question. So we are going to do now question number 3. Question number 3, find the LCM and HCF of the following integer by applying prime factorization method. This is very easy one. Okay. So it is question number 1. It is what? 12, 15, 21. So 12, if you factorize, it will come what? 2 into 2 into 3. So 2 into 2 means what? 2 to the power 2 into 3. 15 if you factorize, 3 into 5. 20 if you factorize means take an LCM. So 7 into 3. So LCM is what? Product of all. So 2 here, 2 to the power 2. 3 is common in all, so only 1 3 will take. See 1 1 here also, everywhere 3 is there, so only 1 3 into 5 into 7. So if you multiply all this, you will get 420. That is LCM equal to 420. HCF, what is common in all the 3? 3 is common, so HCF will be 3. Always remember the one which is common in all, that will be the HCF. Okay. Now 17, 23 and 29. So 17 is factor is what? 17 into 1 only we can write 23. 23 into 1, 29, 29 into 1, because it cannot be factorized, so into 1. So LCM here will be what? 17 into 23 into 29 into 1, so it will come same. HCF, what is common in all the 3? 1, so HCF equal to 1. So dear students, question number 3, 1, 2 I have done, and 3 is left. Okay, Roman number 3, you try it by yourself, it is very easy. 8, 9, 25. Okay, now all of you, we can go to question number 4. Okay, 4, and once again I want to tell you that this question number 4 is important. Okay, for your board exam, this is important. Okay, so question number 4, what it is said, let me read out the question. Given HCF of 306 and 657 is equal to 9. So this is given. HCF of these two numbers is equal to how much? 9. It is given. Now they are telling us find the LCM. It means they have given HCF, they are asking us to find the LCM of these two numbers. So we know one formula, we have already proved it in question number 2. HCF into LCM equal to product of the two given number. The two given number is this one, these two ka product. Okay, so we'll write HCF value is how much? 9. LCM we don't know. Product of the two number, what is the numbers? 306 into 657. Okay, now this one is in multiplication. If I take this 9 that side, then it will be division. So 9 dividing 306, then how many times it will go? 34. 34 into 657, if you multiply, you will get this much. So which is the required LCM. This question generally comes in board exam for 2 marks. Don't think that exactly same questions will come. The number may be changed, but formulas and the method remain same. Okay, now question number 5, what they are telling. Question number 5, all of you need to listen it properly. Okay, so question number 5, check whether 6n can end with a digit 0 for any natural number n. They are telling that we have to check that 6 to the power n, this one, it can end with a digit 0, means when we are putting the 6 to the power any natural number, 6 to the power 1, 6 to the power 10, 6 to the power 100, anything. If you are putting 6 to the power any natural number, then is it possible to get, suppose 6 to the power 2, we are putting it, then what we will get? 36. What is the end digit? 6. So they are telling us to check whether it is possible to put 6 to the power any natural number, means 1 to 100,000 millions, whatever you want to put. Is it possible that if you put any power to the power, any power for 6, is it possible to get the number which ends with 0 at the last? That one we have to check it. So we are checking 6n ends with the digit 0 for any natural number n. We are assuming that 6 to the power n ends, let, means assumption, it is not true, we are assuming it. Let 6 to the power n ends with the digit 0 for any natural number n. Okay, so here n is what? Is a natural number. Okay, now then if 6 to the power n ends with the digit 0, then we know very well any number which ends with 0 or 5, it is divisible by what? Divisible by 5, right or not? We know that if a number ends with 0 or 5, that means it is divisible by 5. So that means we are assuming that 6n ends with the digit 0. That means 6 to the power n is there. When you multiply, you will find, we are assuming that the n number will come 0. So if it comes 0, that means 6 to the power n is divisible by 5, because if the 0 is the end, then that particular number is divisible by, if the last digit is 0 and 5, then that number is divisible by 5. So here we are assuming that it is 0, so then we have assumed it, then 6 to the power n is divisible by 5. It's an assumption, okay? If it is divisible by 5, then what does it indicate? It indicates the prime factorization of 6 to the power n must contain the prime 5. Okay, that means when you are having a prime factorization means like this type. Now I have already told you in question number 1 what is prime factorization. So prime factorization of 6 to the power n must contain the prime what? 5. But we know that when you multiply anything to the power 6, you will be getting either 2 and 3, because 6 ka factor is what? 6. If you prime factorize it, then you will get 2 into 3 or not. But here we are assuming what? 5. Therefore, since 2 and 3 are the only prime factor of 6 to the power n, but here we are putting it what? Prime factor 5, which is not possible. So we have written here which is not possible, okay? Thus, there is no prime in the factorization of 6. So there is no prime. We are assuming that the prime is what? 5, but there is no 5 in the factorization of 6, right or no? So we have written, thus there is no prime in the factorization of 6. So if there is no prime in the factorization of 6, that means our assumption, the first line, becomes wrong. Okay, hence there is existence of no number belongs to natural for which 6 to the power n ends with the digit 0. Okay, so all of you will take it down, this one. This questions is not that important, but still you can take it down. Okay, now we will be going to the next question. Okay, so question number 6. Question number 6, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. Okay, so remember, composite numbers means those numbers which should not have a factor other than 1 and number itself. मतलब एनेगा number जुन जो multiply, suppose let's assume 29. So 29 is a composite number. Is not a composite number. Why? Because 29 into 1. There is there any other factor it can be done? No. It is only 29 into 1. So those numbers which have only 29 into 1, they are not composite number. But those numbers which has factor other than 1, they are called as what? Composite number. Okay, now those which have factors other than 1. Okay, here 29 does not have factors. 29 does not have any other factor. Is it possible to take an LCM of 29? No. 29 does not have any other factor except 1. So this one will not be considered as composite number. Okay, got it? If it has like 25 has a factor 5 into 5. So it is a composite number because it has a factor other than 1. Other than 1 also it has a factor. What is that factor? 5. So 25 will be considered as what? Composite number. But if it does not have any factor other than 1, like 29 into 1, so here factor is only 1. So this kind of number we call it as what? Not composite number. Okay. So they are asking us to explain why this number is composite. So this number we have taken, if you multiply 13 into 11 into 13, 7 into 11 into 13 plus 13. So you will get what? How much? 1001 plus 13. So when you add it, 1014. So this is not a prime number. Why it is not a prime number? Because it has factor other than number itself. See here, this one has prime factor 2, 13 and 3 other than one number and 1. Although number charina, one or number itself charina, if there is any other factor, then that particular number is not a prime number. Okay, so which is not a prime. Therefore, hence this one is a composite because it has other factor also, 2, 13, 3. These are also the factor of this, so it will be considered as composite. Okay. Similarly, 7 into 6 into 5 into 4 into 3 into 2 into 1 into 5 plus 5. So this one, if you multiply and add it, you will get this one. So if you see, if you take LCM, you will get the factor of this one 5. It will come, right or not? So since it is having factor other than 1, therefore it is not prime. And if it is not a prime, it is a composite. Hence this is a composite number. Okay, you can write it here. Hence this is a composite number. Okay. Okay, fine. Now the last question is, in the last question it is said, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round. So 18 ka prime factors, we will write it 2 into 3 into 3. So it is coming how much? 2 into 3 to the power, how many 3 are there? 2. So 3 to the power 2. And Ravi takes 12 minutes. 12 minutes ka prime factor 2 into 2 into 3. So 2 to the power 2 into 3. Now they are telling, suppose they both started from the same point and at the same time go in the same direction. After how many minutes will they meet again in the starting point? So that means what? They are asking us to find out the LCM, nothing else. So LCM is equal, LCM of 18 and 12 will be how much? Here what is the highest one? 3 to the power 2. So 3 to the power 2, here highest one is 2 to the power 3. So you have taken it, multiply 2 to the power 2 is how much? 4, and 3 to the power 2 is how much? 9, 36. Hence Sonia and Ravi will meet after 36 minutes at the starting point. Okay students, so this exercise was very easy. This is the end of your exercise 1.2. I hope all of you are practicing at home properly. Okay, in the next video lecture, okay, we will be doing exercise 1.3 and 1.4. so with that we will finish up chapter 1. Okay, so now with these 7 questions we are coming to the end of your exercise 1.2. okay, and if you are if you are new to the channel, don't forget to like, subscribe and share your mathematics channel Kumar Sir with your friends, and keep watching, keep learning. Thank you.